Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to wiring the 4Y and 2Y connection of PLC S7-200 SMART CPU SR30 with the analog module EM AM03. Okay. This is just a example about how to connect the transmitter 4Y transmitter temperature and 2Y temperature transmitter to the analog input module of PLC S7-200 SMART. In this module, there are 2 points or 2 channels of analog input and 1 channel for analog output. Okay, I will detail about how to connect and how to wiring. And for the module number 1, I will connect 4Y current from transmitter 4Y, yes, temperature around 32 degrees Celsius, connect to 4Y. And for 2Y transmitter, I already connected the thermocouple for this signal. And for power supply, I will detail on the drawing, yes. And then I will connect to the channel number 2 of analog module, okay. And I will use LAN cable connect from here, connect to the Ethernet switch, and one more port I will connect to HMI, and one more port I will connect to computer. So computer will access to both devices. One is PLC and another one device is HMI. So I will use the SIMATIC Step 7 MicroWin Smart version 2.5 and WinCC Flexible to create a new project to download to the HMI MP277 10-inch touch. Okay. So before go to communication and configuration, I would like to explain about how to wiring for detail. Okay, because wiring is very important. So if we cannot wiring the terminal, we cannot test anything. Okay, so let's go to wiring. I will explain step by step. Okay, here is the detail of wiring connection. So right now we have PLC S7-200 SMART CPU SR30, and here is the expansion module analog EM AM03. So first we need to put the power supply 24 voltage from this module, from this circuit breaker to the supply of PLC. And one more, we need to put the power supply 220 volt AC to transmitter 4Y and connect the Pt-100 or RTD to this terminal, and then it will generate the current, follow the range that we setting on the transmitter. So I will connect to the channel number 1, yes, here, plus and minus from the current. It is the 4Y connection. And for 2Y connection, I have power supply input 220 volt AC and output 24 voltage DC. I will connect the plus to the terminal of transmitter, and one terminal I will connect directly to the analog input of PLC. Okay, so it will series with the transmitter, and here is the thermocouple that I already connected the cable to the input of transmitter. Okay, so this is a 2-wire transmitter and this is a 4-wire transmitter. Okay, and normally we put the voltage from L plus to L plus, M to M, to supply the terminal, the card, yes, of expansion analog modules. Okay, so don't forget, connect from here to here. I'm not draw because we know already about in the previous video, so we must connect from L plus to L plus, M to M, to supply the expansion module. Okay, so this is just a drawing detail about how to connect or wiring from 4-wire transmitter to the analog channel and 2-wire transmitter to analog channel also. Okay, so it different. This is a parallel with channel of analog, and this is a series for supply the analog also. Okay, so we will back to our software to configuration and download to show the actual temperature on the HMI. Okay, so let's go to our software. So first let's open SIMATIC SMART. Yes, here. Right now we will use 2.5 version. Yes, and we need to go to the CPU for setting the CPU, right? So first choose the CPU that match with the hardware. Right now I will use the CPU SR30, yeah, because my hardware is SR30. And for SB we can use battery. And for EM expansion module 0, I will use the model number to match with my hardware also. Okay, so right now I will use EM AM03, EM AM03, right? Okay, here. So 2 AIs and 1 AO. Okay, so analog input is 2 channel and analog output is 1 channel, and the address will start from AIW16 and earn AIW18, and for analog output it will start from AQW16. Okay, so first we need to setting the channel number 0. So for channel number 0, I will choose current and start from 0 to 20 milliamp. But for our slide is 4 to 20 milliamp, right? So we need to convert. I will explain about how to convert. So for channel number 1 is the same, and for output I will choose current also, or we can use a volt. It's up to you, because right now I not use the output. Okay, we use only input. And for CPU we need to setting also, example start up, we need to start run. Yes, okay. After that click OK and then go to communication, right? We need to search the communication between our PC with the PLC. So if we use LAN cable, we need to choose the hardware of Ethernet card to match with the connection of LAN cable that we already connected. Okay, so right now I will use this one. Yes, when click here it will found the CPU. Yeah, so right now we found the CPU that has address 192.168.0.2, and this is the MAC address. We can compare with the hardware that already stick on the PLC. If everyone would like to set any hardware of CPU IP address, we can click edit, yeah, and we can change the hardware configuration to match with our process or some device that we want. Okay, so if we click like this, we cannot click OK, right? So we need to put the manual of IP address to be the same as the rank of this one. Okay, so let's go. This is the step for connect to the CPU. Otherwise we cannot connect. If I click OK, let's test. It will alarm occur, right? So we need to put the manual, otherwise we cannot ping. Yes. Example, I ping 192.168.0.2. Oh, we can ping, right? Let me check. Maybe my computer IP address is already put. Okay, we need to put the IP address. Otherwise, we cannot connect to another device. Example, HMI. Yes. So I will put 192.168.0.253. Okay. And then we can click OK. Otherwise, we cannot click. So we need to put the turn off the window firewall also. Yeah. Otherwise, we cannot connect to the HMI. So we need to put off for temporary. Okay. And right now the hardware configuration is already setting up. Yes, already set up for channel number 1 and number 2 of analog input. So we need to create the program scale from 0 to 20 milliamp and for to 20 milliamp, right? So example, if we write like this, we can test. Example, move word. Okay, I will show the step. If we move AIW16, right, it is the address of channel number 1 to VW0, and then we can download and we can start the CPU and then online. So we will got the raw data from the analog input signal that connect from the temperature transmitter, right? Example, one more take. VW4, yes, and then download, and we can monitor also, yes. So this one should be AIW18, right? Okay, so we can download and then see the signal raw data from the analog, right? So we need to convert from this one to match with the rank, right? Okay. So to create the scaling, I already show on the previous video. So in this video, I will import the block, converter block, to show to everyone, right? So here is the block scaling that we already learned in the previous video. So I will use this block. So to use this block, let's go to call subroutine, right click and then import. We can save the project. Example 2y, 4y and 2y. Tutorial. Okay. And then we can import from the block right here. Okay. And then we will got this block. And we can also check before use. Okay, this one we can open to check. Okay. So this is a variable of this block, and we already created. Yes. And we can also import another blocks that we want. Example, I will choose this block. Okay. And then we can also open to check. Yes. Like this. So we have two blocks. One block is scale analog input and one block is scale in and out. Okay. So we can use. So to use this block, let's go to drag and drop this block to use, right? Drag and drop. Okay. And then we can connect like this. Actually, we cannot. We no need to use this block, so we can delete. It just tests the analog signal. Okay. And here is the block that convert from scaling of analog input. Yeah, we have high scale in, low scale in, high scale out, and low scale out, and we will got output. Okay. So first, I will insert the input, right? So we need to convert from integer to real because this block is real for input. Let me show the data type of this block. Let's see, here is the real. Yes. So here we need to convert from integer to real, right? So we can drag here. So integer, convert from integer to double integer, and from double integer to real, right? Okay. And for this one is AIW16. It is the address channel number 0. And here we need to create the temporary variable. Example tempo1. Tempo1, it is the double integer, right? So double integer. So here we can use tempo1, and this one tempo1 also. Yes. And for this one we need to insert one more variable. Example tempo2. and the data type is real, right? So tempo 2 is real, and then here we can use tempo 2, yes, because we need to convert this output, right? Okay, I will connect this one. And for the scaling of transmitter, yeah, of this transmitter is from 0 to 100 degrees Celsius. Okay, so here I need to put 100.0 degrees Celsius, and here is the value of analog. For high scale of analog, input is 27648.0, right? And for 4 milliamp around 5500.0, because I already test 4 milliamp. This is the value of 4 milliamp, and this is the value of 20 milliamp. Okay, and we will got the output for show on HMI. Example MD example MD0, yes, and then we can save the project and then download to the PLC, and we can online. Okay, so right now temperature show around 22, yeah, 21 something, yeah, the same as the transmitter. Okay, I will show after we create one more transmitter, one more signal finish. Okay, so we need to create one more for channel number 2 or transmitter number 2, right here, and this one rank from 0 to 150 degrees Celsius, connect from thermocouple. So we need to insert one more, right? Or we can connect from here. Example, I will convert from double integer to real, integer to real also, right? And then we can use this scale also. Yeah, then we can connect for channel number 2. And this one I will change to AIW18, right? Hardware configuration. Start from 16, yeah, earn 18, okay? So channel number 2 is AIW 18 here, and here I need to create one more for temporary variable. So tempo 3, it is the double integer 2, right? So tempo 3 here, and here is tempo 3 also. And for the real value, I need to insert one more for tempo 4, and the data type is real. So tempo 4, and here we can copy and then paste here for tempo 4. And the signal is the same for 20 milliamp around 5500, and 20 milliamp it is the standard 27648.0, and here is the scale of transmitter, so 150 degrees Celsius 0.0, and here is the address that we will show on the HMI. So we can write MD10, yes, okay, and then we can save and then download to the CPU again, and then we will online to see the actual temperature, yes. So right now it show around 25 degrees Celsius, and another one show around 22 degrees Celsius. Okay. For more detail, we can check here. Yes, because I already created the formula since we learned in the previous video for scaling. Yeah, and here is the parameter that we need to set. Input high scale, low scale in, high scale in, low scale out, and high scale out here. Yes, so we can check. Okay, so right now we already show the actual temperature, so we need to create the HMI to show this value and this value to HMI, right? So let's go to WinCC flexible. So first, let's open WinCC flexible. Create the empty project, and let's check the panel that match with our panel hardware, right? Okay, let's check. For me, I use the TP, yes, MP. I use MP 27710 in touch for the hardware. Yeah. So we need to choose the hardware to match with our HMI. Otherwise, we cannot connect and simulation, or we cannot download the project to the HMI, right? Okay, so make sure we already put the correct model number of HMI. Okay, then we can change the property of screen. For me, I like this color. Yes, I will change to this color. Yes, we can change another color that we want. Yeah, example this color or this color or another color that we want. Yeah, this color. For me, I like this color. Okay, so I will change to this color. Then we need to create the connection, right? Create the connection here for connect from HMI to the PLC, right? So first, create the connection. Example, connect to PLC SMART. Yes. And here is the driver communicator. So we need to choose the correct. Right now, I will choose SIMATIC S7-200. And I will choose Ethernet module. Yes, Ethernet connection, because right now we use LAN cable, right? So here is the address of computer. So 192.168.0.253, right? It is the computer IP address here. 241, right? Okay. Two five three. Okay. And here is the IP address of PLC. So 192.168.0.2, right? Okay. Yes, I will show here. Yes, here is the IP address of PLC. So we need to put the same. Here is the IP address of computer, and here is the IP address of PLC. Okay. And then go to create the text. Go to the text folder or text tab. So the first one is sensor 1, right? And the data type is real. So we choose real. And the address is MD0, right? So MD0. And we can command something. Example, actual value of temperature sensor 1. And we need to create the sensor 2, right? Okay. The real value also. So example, this one is MD10. So we need to put this one is MD10. And we can command. Okay. And then we need to create the screen, yeah, to show the actual value. I will choose the text. Example, connect 4Y and 2Y connection from transmitter to PLC. You can go property and then go to text layout and then uncheck this one. Otherwise we cannot adjust the space of this text, right? And we can adjust the font size. To be 14. Okay, 14, and then change the color to be yellow, right? For easy to see, yeah. Okay, to PLC S7-200 SMART CPU SR30 plus EM AM02. Okay. Okay, I will change the color to this color. Okay. And we need to insert the I/O file, yes, to show the value of temperature, right? The same as the previous video. So here is the output. And the format is like this. And then we can change the font size to be 24 or 28. And for this one, okay, like this. And for the text color, we can change to this color. And for background, we can change to this, and we can go to align to be middle and center, and this one we can choose solid and choose the color like this. Okay, for sensor number 1, so we can copy and then create for sensor number 1 for Y. Then we can increase the font size to be 24. For Y, yes. Actually, we can design the style that we want, yes. So we can adjust to be aligned, yes. And then we can copy for sensor number 2. It is sensor number 2 is to Y from transmitter, right? So I will choose the color with Y color, and then I will create for unit. The gray Celsius, right? So the unit is the gray Celsius. I will adjust this one to be 9. Okay, and then we can group. Okay, we can group like this. Okay, and then we can choose the text, yeah, for sensor number 1. Actually, we can increase this one to be 14 or 16. Sixteen is okay, right? Maybe 17. 15, right? Actually, we can create like this. I will copy this one. Okay, Control 8 this one, and then paste here. Okay, like this, and we can increase this one to be like this. Okay, like this. And we can create the text, yeah, output, and we can choose the text here, sensor 1, and here for sensor number 2. Then we can save the project. I will insert a new folder for this project, example 4Y, 2Y. Okay. And then we can simulation before go to download to the HMI. So we can simulation. Okay, right now the channel number 1 show around 21 and channel number 2 show around 26 degrees Celsius. Okay, so let's download this project to the HMI and then let's see the condition on the HMI. To download this project to the HMI, I would like to explain a little bit how to download and how to setting before download. So let me show. So first let's go to the close and then go to control panel and then go to the transfer. Make sure we connect via internet, yeah, internet, because right now we use LAN cable, and go to advanced to check the IP address. Make sure the IP address is made with the same with our computer, example 192.168.0.10, yes. And then go to the transfer setting. Make sure we connect and select to the S7 Ethernet, yeah, and then click OK and go to transfer, yeah. And go to the project of WinCC flexible and then please download and choose the Ethernet, right? Because we use Ethernet LAN cable, so we need to put IP address of HMI, right? So 192.168.0.10, right? It is the HMI IP address. And then click OK to confirm. Yes, to confirm. So it will transfer the project file from our computer to the HMI, and then it will automatically start. Okay. So let's see here. The temperature of channel number 1 is show 21 degrees Celsius, and channel number 2 is show around 25 degrees Celsius. Okay. So if I hit the Pt-100 or Thermocouple, okay, I will hit the sensor. Let's see the temperature start increase. It's 1 also for channel number 1. Let's see, start increase. And the HMI is show the same as the transmitter. Will start increase, hit more. Yes. So the communication between HMI and PLC is okay. And the PLC is show the actual also, and we can simulation. Yes. Okay, I will hit more. $50, $70, $80 degrees Celsius. Okay. So this is just example about how to communication and wiring the 4-wire connection and 2-wire connection from temperature transmitter to the PLC S7-200 SMART. Okay. So the communication is very important here. If we cannot communication and wiring, we cannot do anything. Yes. So we need to choose the correct network that we connect to the PLC. Yes. And for HMI also, we need to connect and download to the HMI. Okay. And one more thing for connection wiring is the most important. Yes. For communication and test with the PLC. Otherwise, we cannot test if we cannot wiring the connection. Okay. So thank you very much for watching my video. And if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye.